December 16th, 1944. Ardennes Forest, Belgium. Master Sergeant Paul Harmon stood beside his Sherman tank, his breath forming clouds in the bitter pre-dawn air. Snow blanketed the forest around him, muffling the sounds of the 2nd Armored Division preparing for the day. At 43, Harmon was older than most tankers. His weathered face, permanently etched with grease stains from years as a Pennsylvania oil field mechanic before the war, showed concern as he studied the ammunition feed system of his M4 Sherman. "Problem, Sergeant?" asked Captain William Dwight, the company commander, making his morning rounds. "Yes, sir," Harmon replied, not looking up from the open ammunition bay. These feed trays were designed by someone who never had to reload under fire. His calloused fingers traced the standard ammunition system that required loaders to hand-transfer 75mm shells from storage boxes to the gun breech, a system that inevitably slowed or failed during extended engagements. "We've all got the same equipment, Sergeant," Dwight answered with a shrug. "Germans aren't complaining about their ammunition systems." "Germans don't need to complain, sir," Harmon countered, finally looking up. "Their Panthers can punch through our frontal armor at 1,000 yards. We need to put 3 or 4 rounds into them, hitting just right, to have a chance. And we can't do that if we're constantly fighting our own feed system." Dwight moved on without comment, but Harmon remained fixed on the problem. In civilian life, he had been known for mechanical innovations that improved oil pump efficiency. Now, facing the most important mechanical challenge of his life, he saw a solution where others accepted the status quo. What Harmon could not know was that in mere hours, the largest German offensive since 1940 would crash into the Allied lines. His improvised solution to the Sherman's ammunition feed problem would soon face the ultimate combat test and reveal a fundamental American advantage that German commanders had fatally underestimated. The Battle of the Bulge began at 5:30 that morning, when over 2,000 German artillery pieces opened fire along an 80-mile front. The German offensive caught the Allies by surprise, driving deep into the Ardennes forest. The weather, heavy snow and dense fog, neutralized Allied air superiority, allowing German armor to advance rapidly against unprepared American positions. As the devastating news reached 2nd Armored Division headquarters, Harmon was in the division maintenance depot, working with a small team of mechanics on his unorthodox project. Using salvaged parts from damaged Shermans, discarded ammunition crates, and materials scavenged from abandoned Belgian farmhouses, he was constructing something the tank manuals never envisioned: a continuous feed ammunition system that could transform the Sherman's combat effectiveness. "This is a waste of time, Paul," said Technical Sergeant Frank Mullins, watching skeptically as Harmon modified standard ammunition boxes by removing one side and adding guide rails made from salvaged track pins. "If Detroit engineers couldn't figure this out with all their fancy equipment, what makes you think you can solve it with scrap metal and baling wire?" Harmon didn't look up from his work. "Detroit engineers never had to sit inside a burning Sherman because they couldn't reload fast enough," he answered, his voice matter-of-fact rather than defensive. "Besides, they're designing for mass production. I'm designing for survival." The core of Harmon's innovation was deceptively simple. Rather than storing 75mm shells in separate boxes that required individual handling, his system used modified containers arranged in a gravity-assisted sequence. Shells would slide down a track, guided by rails made from tank track pins, allowing the loader to maintain a continuous feed rate during intensive engagements. Most importantly, the entire system could be constructed from salvaged materials available at any forward maintenance depot. By mid-afternoon, as news arrived of German Panthers breaking through American lines near Losheim, Harmon was testing his prototype on his own Sherman. The division maintenance officer, Lieutenant Colonel Robert Harrison, approached with obvious skepticism. "Sergeant, I've been hearing about your project," Harrison said, examining the crude-looking assembly of modified ammunition boxes and metal rails attached to the standard ammunition bay. "This looks like something from a backyard garage, not U.S. Army equipment." "With respect, sir," Harmon replied, continuing his adjustments, "American garages have produced some damn fine innovations. This may not look pretty, but it will keep us firing when it matters." Harrison ran his fingers along the improvised guide rails. "How many rounds per minute?" "Standard loading. We manage maybe 4 to 5 rounds per minute sustained fire, before the loader gets overwhelmed," Harmon explained. "With this system, we should maintain 8 to 10 rounds indefinitely, double our effective firepower without changing the gun or ammunition." "And when it jams in the middle of combat?" Harrison challenged. Harmon pointed to specific features of his design. "There's no complex moving parts, sir. If a shell sticks, the loader can clear it in seconds from his position. Everything's designed to be fixed or replaced with basic tools and salvaged materials." Harrison remained unconvinced, but the rapidly deteriorating tactical situation made experimentation more palatable. "Fine. Install it on your tank for testing. But if it fails during engagement, you're personally responsible for any consequences." As Harrison walked away, Sergeant Mullins shook his head. "He's right about one thing, Paul. If this contraption fails when we're facing Panthers, we're dead men." Harmon tightened the final bolts on his creation. "And if we stick with the standard system, we're dead anyway. At least this gives us a fighting chance." That evening, as the full scope of the German offensive became clear, 2nd Armored Division received urgent orders to move toward March, Belgium, to help blunt the German advance. With no time for formal testing, Harmon's modified Sherman joined the convoy heading east into the gathering darkness, his improvised ammunition system about to face the crucible of combat. The planning and expectations behind the German Ardennes offensive contrasted sharply with the improvised American response. Codenamed Operation Watch on the Rhine to suggest a defensive posture, the attack represented Hitler's desperate gamble to split the Allied forces with a thrust toward Antwerp, potentially forcing a negotiated peace on the Western Front. General Oberst Alfred Jodl, chief of the operations staff of the German Armed Forces High Command, had meticulously orchestrated the assembly of 24 divisions, including 10 panzer divisions with over 900 tanks, in complete secrecy. The offensive had several key advantages: surprise, concentrated force, and weather conditions that neutralized Allied air power. What German planning failed to account for was the American capacity for improvisation when standard equipment and tactics proved insufficient. While German forces relied on rigid adherence to detailed plans created by Central Command, American units frequently modified both equipment and tactics based on battlefield experiences. This fundamentally different approach reflected deeper cultural and industrial divergences between the two military systems. German tank commander Hauptmann Franz Bayecke of the 2nd Panzer Division personified the German perspective. A veteran of campaigns in Poland, France, and Russia, Bayecke commanded 5 Panther tanks advancing through the Ardennes. His training emphasized strict maintenance protocols and standardized combat procedures. German panzer crews operated their tanks exactly as specified by technical manuals, with modifications prohibited, as they might compromise reliability or logistical standardization. "Our strength lies in precision and technical superiority," Bayecke noted in his campaign diary on December 16th. "Each Panther can destroy multiple Sherman tanks at ranges where the Americans cannot effectively return fire. Superior engineering will overcome superior numbers." This confidence reflected actual technical advantages. The Panther's 75mm KWK-42 gun could penetrate a Sherman's armor at over 1,000 yards, while the Sherman's 75mm M3 gun struggled to penetrate the Panther's frontal armor at any practical combat range. German commanders believed this qualitative edge would overcome American quantitative advantages, a perspective that failed to account for American mechanical improvisation, exemplified by Harmon's ammunition system. As German forces advanced, pushing back unprepared American units, the 2nd Armored Division, nicknamed Hell on Wheels, moved to counter the northern shoulder of the German breakthrough. The division's Combat Command B, under Colonel Paul Connor, deployed near Hotton, Belgium, on December 19th, establishing defensive positions as German reconnaissance units probed the area. Harmon's tank, now bearing his modified ammunition system, took position on the eastern edge of Hotton. Through the night, he made final adjustments to his creation while explaining its operation to his crew. Private First Class Daniel Ross, the tank's loader, initially regarded the contraption with suspicion. "This doesn't look like anything in the training manual," Ross observed, studying the ungainly assembly of salvaged parts. "That's because the training manual was written by people who expected us to retreat after firing a dozen rounds," Harmon replied. "Tomorrow, we might need to fire 100 without stopping. This system will let you feed shells continuously without getting overwhelmed." Ross practiced with the system, finding that shells indeed flowed smoothly down the guide rails with minimal effort, allowing him to maintain a loading rhythm that would have been impossible with standard equipment. By dawn, the crew had developed confidence in their commander's innovation, though none could anticipate how severely it would soon be tested. The intelligence assessments and preparations leading to the confrontation near Hotton revealed the stark differences in American and German approaches to warfare. German intelligence, directed by Admiral Wilhelm Canaris's Abwehr, had accurately identified the Ardennes sector as lightly defended by inexperienced American units. What they failed to appreciate was the speed with which American forces could adapt to battlefield challenges through improvisation rather than formal planning. American intelligence, meanwhile, had catastrophically failed to detect the massive German buildup, with Major General Kenneth Strong, Chef G2, dismissing indications of German offensive preparations as defensive measures. This intelligence failure placed even greater importance on the ability of American units to adapt quickly when surprised, precisely the quality embodied in Harmon's improvised ammunition system. As dawn broke on December 20th, the strategic situation in the Ardennes had reached a critical juncture. The German 5th Panzer Army, spearheaded by the 2nd Panzer Division, was driving toward the Meuse River crossings. If they could cross the Meuse, the path to Antwerp would be open, potentially splitting the Allied forces. Standing in their path near Hotton was the 2nd Armored Division, including Master Sergeant Harmon's modified Sherman tank. In the pre-dawn darkness, Harmon's crew performed final equipment checks. Private Ross ran his hand along the improvised ammunition feed system one last time, ensuring shells would flow smoothly when needed. The radio crackled with reports of German armor approaching from the east. Elements of the 2nd Panzer Division's reconnaissance battalion probing for weaknesses in the American lines. "All tanks, this is commanding officer." Colonel Connor's voice came over the radio. "German armor approaching grid sector 49er. Expect Panthers and infantry support. Hold positions and engage at optimal range." Harmon's driver, Corporal James Withers, started the Sherman's Continental R975 radial engine. The massive 9-cylinder aircraft engine roared to life, sending vibrations through the 33-ton vehicle. Gunner Sergeant Lee Phillips peered through his telescopic sight, scanning the tree line 800 yards to the east. The waiting had begun. At 7:15 a.m., the first German armor appeared, 2 Panther tanks advancing cautiously along the road. flanked by grenadiers in white winter camouflage. Harmon's gunner tracked the lead tank, waiting for the order to fire. At 700 yards, the distinctive sound of the Panthers' high-velocity 75mm gun shattered the morning calm as it fired on an American position to the north. Target identified. Panther, 700 yards, road junction, Phillips called out. Fire when ready, Harmon ordered, his voice calm despite the imminent engagement. Phillips squeezed the trigger, sending the first 75mm shell toward the German tank. Private Ross immediately slid another shell down the improvised feed system, having it loaded before the gunner could even confirm the hit. The Sherman's gun rocked back with each shot, brass casings clattering to the floor as Ross maintained a steady loading rhythm that would have been impossible with the standard system. The first shots struck the Panther's track, immobilizing it but leaving its gun operational. The German tank returned fire, its high-velocity round screaming just over the Sherman's turret. Phillips adjusted aim and fired again, striking the Panther's side armor but failing to penetrate. The technical superiority of German armor was being demonstrated in real time. "We need to hit the side armor at the perfect angle," Harmon instructed. "Keep firing. Don't give them time to aim carefully." This moment, when American tanks needed to overcome German qualitative advantages through quantitative methods, was precisely what Harmon's ammunition system had been designed for. While a standard Sherman would have been struggling with ammunition handling by the fourth or fifth shot, Ross was maintaining a steady rhythm, sending a shell into the breach every 6 to 8 seconds. The sustained fire forced the German tank commander to butt him up completely, reducing his visibility and accuracy. After the 8th shot, a Sherman round finally found the vulnerable junction between the Panther's turret and hull, penetrating to the ammunition storage. The German tank erupted in flames as its crew attempted to escape. The second Panther, witnessing its companion's destruction, withdrew into the tree line. The first engagement had validated Harmon's innovation, allowing his crew to maintain a volume of fire that compensated for the Sherman's technical disadvantages. But this was merely the opening round of what would become one of the most sustained tank battles on the Western Front. By mid-morning, German pressure on the Hotton sector had intensified significantly. Elements of the 2nd Panzer Division's main force arrived, bringing at least 15 Panther tanks and 2 Tiger IIs against the American defenders. Colonel Connor's command deployed its reserves, creating a defensive screen of 36 Sherman tanks supported by tank destroyers and artillery. Harmon's position, covering a critical road junction, soon came under concentrated attack. 3 Panthers emerged from the tree line to his front, while German infantry worked through the woods to the north, threatening to flank the American position. As the Sherman's main gun engaged the lead Panther, Harmon directed the bow gunner to suppress the infantry with the .30 caliber machine gun. "We need to hold this position at all costs," Harmon told his crew as they engaged multiple targets simultaneously. "If they break through here, they've got a clear run to the river." The mathematical disadvantage facing the Sherman tanks was stark. Each Panther required multiple hits to disable, while a single Panther round could destroy a Sherman. Under normal conditions, this disparity would force American tanks to withdraw after brief engagements. But Harmon's ammunition system was changing the equation, allowing sustained fire that kept German tanks on the defensive despite their technical superiority. As the morning progressed, Harmon's tank fired over 70 rounds, far beyond what a standard Sherman could deliver in concentrated combat. The improvised feed system functioned flawlessly, allowing Private Ross to maintain a loading pace that kept German armor at bay. When a feed rail bent after the 80th round, Ross made field repairs in less than 30 seconds using basic tools, exactly as Harmon had designed. By noon, word of the modified Sherman's extraordinary performance had reached Colonel Connor's command post, The sector under Harmon's protection had held despite facing superior German armor, primarily due to the sustained fire capability of his modified tank. What had begun as one sergeant's unauthorized equipment modification was proving to be a critical factor in blunting the German advance. As afternoon approached, the battle for Hotton reached its climax. German commanders, frustrated by their inability to break through the American defensive line, committed their reserves in a concentrated assault. 8 Panthers and 1 Tiger II, supported by 2 companies of infantry, advanced directly toward the American center, including Harmon's position. This moment would provide the ultimate test of American adaptability against German technical superiority, a microcosm of the larger strategic balance on the Western Front. The outcome would hinge not on which side had the theoretically superior equipment, but on which could make most effective use of available resources under actual combat conditions. December 20th, 1944. 1:30 p.m. Hotton, Belgium. The roar was continuous, a sustained thunder of cannon fire, machine guns, and impacting shells that shattered the winter air. Master Sergeant Paul Harmon's Sherman tank had been engaging German armor for over 4 hours without pause, an endurance feat previously thought impossible with standard American tanks. The improvised ammunition feed system, constructed from salvaged parts and dismissed as backyard engineering just days earlier, was enabling an unprecedented sustained rate of fire. 117 rounds expended, Private First Class Daniel Ross called out as he slid another 75mm shell down the guide rails and into the breach. His face was streaked with sweat, despite the December cold, his movements precise, despite hours of continuous loading. The modified ammunition feed system had transformed what should have been an exhausting, nearly impossible task into a sustainable rhythm. Gunner Sergeant Lee Phillips kept his eye pressed to the sight, tracking a Panther tank attempting to maneuver behind a farmhouse 500 yards to their front. "Target traversing right, behind the stone building," he called, adjusting the turret smoothly. The gun roared again, sending its 118th round downrange. The battle for Hotton had reached its climax. 8 German Panthers and 1 Tiger II tank, supported by approximately 200 infantry, had launched a concentrated assault on the American position. Under normal circumstances, such a force would have overwhelmed the defending Shermans through superior firepower and armor. But the battle wasn't unfolding according to the technical specifications on paper. Instead, the engagement revealed the critical human element that German planning had failed to account for: American mechanical improvisation under combat conditions. Harmon's modified Sherman, along with 2 others he had helped retrofit with similar systems the previous night, were maintaining a volume of fire that kept German armor in constant defensive movement, unable to establish the stable firing positions their superior gunnery required. Captain William Dwight, who had dismissed Harmon's modification days earlier, watched in astonishment through binoculars from his command post. "How is that tank still firing?" he asked his radio operator. "They should have exhausted their ammunition hours ago." The radio crackled with Harmon's response to another unit's call. "We've got plenty of ammunition and can maintain this fire rate indefinitely. Tell Baker Company to focus on the infantry approaching from the northeast. We'll keep the Panthers occupied." This moment, when American improvisation directly countered German technical superiority, represented the critical turning point, not just in this local engagement, but in the larger strategic balance on the Western Front. The homemade ammunition system was demonstrating in real time how American industrial philosophy, which emphasized adaptability and field modification, could overcome German engineering advantages. Across the battlefield, Hauptmann Franz Baecke of the 2nd Panzer Division was experiencing the consequences of this disparity firsthand. His Panther tank technically superior in almost every specification to the opposing Shermans, was pinned down behind a small ridge, unable to establish the firing position needed to leverage its advantages. "It's impossible!" he shouted to his gunner over the continuous impact of American shells. "They cannot maintain this rate of fire with their loading system. They must have twice the normal crew in those tanks." See, what Bake couldn't know was that he was witnessing not a numerical advantage, but an innovation advantage. American mechanical improvisation that German military doctrine neither anticipated nor could easily counter. The rigid German approach, which prohibited unauthorized equipment modifications, had encountered its antithesis in Harmon's feed system. At 2:15 p.m., the critical moment arrived. The German attack, stalled by unexpectedly heavy and sustained American fire, began to lose momentum. The Tiger II, which should have been able to dominate the battlefield with its 88mm gun, had been unable to establish a stable firing position due to the continuous barrage from Harmon's tank. When it finally attempted to advance to break the stalemate, 5 consecutive rounds from Harmon's Sherman struck its right track and suspension, immobilizing the massive vehicle. "We've got the Tiger!" Phillips called out as he observed the damage through his scope. "Can't penetrate its frontal armor, but it's not going anywhere." Harmon nodded, directing the gunner to shift focus to the supporting Panthers. "Without the Tiger, they'll lose their nerve. Keep firing." By 3 p.m., the German assault had collapsed entirely. 3 Panthers lay burning on the field, another 2 were immobilized with track damage, and the remainder were withdrawing to regroup. The Tiger II, despite its intact main gun, had been abandoned by its crew after sustained fire set its engine compartment ablaze. Harmon's Sherman had fired 173 rounds during the 4-hour engagement, more than triple what would have been possible with the standard ammunition handling system. The 2 other Shermans he had modified had achieved similar results, creating a defensive firepower that numerically inferior American forces should not have been able to maintain. As the German armor retreated, Colonel Paul Connor, commander of Combat Command B, arrived at Harmon's position. The Sherman's barrel glowed dull red from sustained firing, spent shell casings littered the ground around the tank, and the improvised ammunition feed system, scorched and battered but still functional, stood as testament to American battlefield innovation. "Sergeant," Connor addressed Harmon, who stood atop his tank surveying the battlefield, "I want to see this ammunition system of yours that everyone's talking about." Harmon led the colonel around the Sherman, explaining the improvised feed mechanism in detailed technical terms. His hands, blackened with carbon and grease, traced the path of ammunition from storage to gun breech. "This guide rail is from a damaged track assembly," he explained. "The feed chute is made from 3 standard ammunition boxes with the sides removed and welded together. The entire system can be fabricated in any forward maintenance depot with salvaged parts." Colonel Connor studied the ungainly but effective creation with growing appreciation. "And this system allowed you to maintain continuous fire for 4 hours?" "Yes, sir," Harmon confirmed. "The loader can maintain rhythm indefinitely. The limitation becomes barrel heat, not ammunition handling." Connor turned to his aide. "I want this system documented immediately. Have the division photographer take detailed pictures and get a full report from Sergeant Harmon on materials and fabrication methods. I want every Sherman in the division equipped with this modification within 48 hours. This moment, when improvised field modification became official doctrine, epitomized the American approach to industrial warfare. Unlike the German system, which required factory-level changes approved through a rigorous command structure, American forces could adapt equipment in the field based on combat experience, rapidly implementing improvements without bureaucratic delay. News of the Harmon system, as it was immediately dubbed, spread rapidly through the 2nd Armored Division and beyond. By December 22nd, just 2 days after the battle at Hotton, the improvised ammunition feed was being installed on tanks throughout the division, with maintenance crews working around the clock to retrofit as many vehicles as possible. Lieutenant Colonel Robert Harrison, the division maintenance officer who had initially dismissed Harmon's creation, now found himself overseeing its implementation across the entire division. "I've never seen anything like this," he admitted to Harmon as they supervised a team retrofitting Sherman tanks. "From concept to division-wide adoption in less than a week. This wouldn't be possible in any army, but ours." Harmon, characteristically modest about his innovation, focused on refining the design based on combat experience. "The initial version works, but we can improve it," he explained, sketching modifications on a notepad. "If we angle the feed rails like this, we reduce the chance of shells jamming by about 30%. See, this iterative improvement process, continuous refinement based on field experience rather than theoretical design, represented another fundamental contrast between American and German approaches to equipment development. While German engineers might create technically superior initial designs, American forces excelled at rapid evolution through practical application. The strategic impact of Harmon's innovation extended far beyond the local engagement at Hotton. By December 24th, as the German offensive reached its culmination point, modified Sherman tanks throughout the 2nd Armored Division were demonstrating similar sustained fire capabilities, fundamentally altering the balance of armored warfare on the Western Front. Major General Ernest Harmon, no relation to Sergeant Paul Harmon, commanding the 2nd Armored Division, referenced the innovation in his December 26th situation report to Corps headquarters. "Modified ammunition feed systems have significantly enhanced our armor's combat effectiveness. Tanks equipped with the Harmon system demonstrate triple the sustained fire capability, partially offsetting the enemy's qualitative advantages. Recommend immediate theater-wide implementation." This recommendation quickly reached the highest levels of Allied command. General Omar Bradley, commanding the 12th Army Group, received a demonstration of the modified system on December 28th. After observing a retrofitted Sherman maintain continuous fire for over 30 minutes without loading difficulties, Bradley ordered immediate theater-wide adoption of the innovation. "This is exactly the kind of field-level initiative that gives us an edge," Bradley reportedly remarked. "One sergeant with mechanical aptitude has effectively multiplied our armored firepower without requiring a single new tank from the factories." The German perspective on this development was captured in intelligence reports that initially misinterpreted the American capability. A captured 2nd Panzer Division assessment from late December noted, "American tanks in the Hotton sector demonstrated unprecedented fire sustainability, suggesting deployment of a new model with automated loading system. Technical intelligence should prioritize capture of this apparently new Sherman variant. What German intelligence failed to comprehend was that they weren't facing a new factory-produced variant, but rather the American capacity for battlefield innovation, a capability their own rigid military structure couldn't easily replicate." This fundamental difference in approach to equipment modification reflected deeper contrasts in industrial philosophy between the two powers. By January 1945, as the Battle of the Bulge concluded with the German offensive contained and reversed, the Harmon system had been implemented on over 600 Sherman tanks across the Western Front. The innovation spread through a combination of official technical bulletins and informal tanker-to-tanker knowledge sharing, with maintenance crews adapting the basic concept to various Sherman models. Captain William Dwight, who had initially dismissed Harmon's modification, became one of its most vocal advocates. In a January 4th report to division headquarters, he wrote, The improved ammunition handling system has fundamentally altered our tactical approach to German armor. Where previously we were forced to fire a few rounds and then maneuver due to loading limitations, we can now maintain suppressive fire that negates the enemy's technical advantages through volume and sustainability. The wider strategic implications became apparent as Allied forces resumed their advance into Germany in February 1945. German after-action reports increasingly noted the changed nature of engagements with American armor. A February 10th assessment from the German 7th Army observed, "American tanks now maintain continuous fire during extended engagements, preventing our armor from establishing optimal firing positions." This represents a significant tactical shift that our current doctrines do not adequately address. What German analysts couldn't fully articulate was that they were encountering not just a technical modification, but a fundamentally different approach to industrial warfare, one that emphasized adaptability, field improvisation, and rapid implementation of lessons learned. The Harmon system exemplified this approach, having gone from unauthorized field modification to standard equipment in less than 2 months. For Master Sergeant Paul Harmon himself, the impact of his innovation brought recognition but little change in personal circumstances. He received the Bronze Star for his actions at Hotton, with the citation specifically mentioning his technical innovation that significantly enhanced combat effectiveness under fire. Yet he continued serving as a tank commander, participating in the advance into Germany while continuing to refine his original design. When asked by a visiting war correspondent about his invention in March 1945, Harmon characteristically downplayed his contribution. Any decent mechanic would have seen the same problem and come up with something similar. I just happened to be the mechanic in the right place at the right time. This modest assessment belied the broader significance of what Harmon had achieved. His innovation demonstrated how individual initiative within the American military-industrial system could impact strategic outcomes, a capability that German forces, despite their technical excellence, struggled to match. As Allied forces drove deeper into Germany in the spring of 1945, capturing intact German equipment provided further insights into the contrasting industrial philosophies. German tanks like the Panther and Tiger were masterpieces of engineering, technically superior in armor, armament, and design to their American counterparts. Yet these same tanks required specialized maintenance, depot-level repairs for even moderate damage, and factory-trained technicians to maintain optimal performance. By contrast, the Sherman, even with its inferior armor and armament, could be maintained, modified, and returned to combat by soldiers with basic mechanical training using tools and parts available at forward maintenance units. Harmon's ammunition feed system epitomized this advantage, enabling significant performance enhancement without specialized equipment or expertise. Colonel Crichton Abrams, commanding Combat Command B of the 4th Armored Division and future Army Chief of Staff, summarized this contrast after examining captured German tanks in April 1945. The Germans built magnificent machines that required factories to maintain. We built serviceable machines that soldiers could improve in the field. In modern warfare, the latter approach proved decisive. The mathematics of defeat that German forces encountered on the Western Front thus extended beyond simple production numbers. While American factories indeed outproduced their German counterparts by overwhelming margins, 49,000 Sherman tanks versus less than 6,000 Panthers and Tigers combined, the ability to modify and improve equipment in the field multiplied this advantage further. A captured German maintenance officer, interrogated in April 1945, provided insight into this disparity. When our tanks suffered track damage, we required factory-manufactured replacement parts transported from Germany. When American tanks suffered similar damage, they fabricated replacements from damaged vehicles. When we needed to improve performance, we redesigned at the factory level. When they needed improvement, they modified in the field. This fundamental difference proved more significant than any technical specification. The legacy of Harmon's innovation extended well beyond World War II. The concept of field expedient modification became ingrained in American military doctrine, with the understanding that frontline users often develop practical solutions that engineers and planners might never conceive. Modern American military equipment is designed with modification in mind, incorporating standardized attachment points and deliberately accessible systems that facilitate field adaptation. This approach, empowering users to modify equipment based on operational experience, represents a distinctly American industrial philosophy that contrasts with more centralized design approaches. From the Vietnam-era gunners, who strapped extra ammunition boxes, to helicopter door mounts, to modern soldiers fabricating vehicle armor enhancements in Iraq and Afghanistan, Harmon's legacy of field innovation continues. The homemade ammunition belt that kept Sherman tanks firing for 4 hours straight at Hotton thus stands as more than an interesting technical footnote in military history. It represents a fundamental American advantage that continues to influence modern warfare. The democratization of innovation, where solutions can emerge from any level of an organization rather than flowing exclusively from top-down design authorities. In 1945, as the war in Europe concluded, Army ordnance officers documented the Harmon system as part of a comprehensive review of field modifications that had proven effective in combat. Their report noted, "This innovation, created entirely from salvaged materials available at forward maintenance units, effectively tripled the sustained fire capability of Sherman tanks without requiring factory modification. It demonstrates how frontline mechanical improvisation can significantly impact combat effectiveness." What began as one sergeant's unauthorized tinkering with standard equipment ultimately contributed to shortening the war in Europe by enhancing American armored capability at a critical juncture. The Battle of the Bulge, Hitler's last significant offensive, was blunted not just by Allied numerical superiority, but by the adaptability and innovation embodied in modifications like Harmon's ammunition system. Master Sergeant Paul Harmon returned to Pennsylvania after the war, resuming his career in the oil fields. He rarely spoke about his wartime innovation, considering it simply part of his job as a tank commander and mechanic. When pressed by family members, he would typically respond, "We had a problem, so I fixed it. That's what Americans do." This modest assessment perhaps best captures the essence of the American advantage that Harmon's innovation represented. In a contest between German technical perfection and American practical adaptation, the latter proved decisive, not just at Hotton in December 1944, but across the entire European theater of operations. The ultimate vindication came from German Field Marshal Gerd von Rundstedt, who commanded the Ardennes offensive. In his post-war assessment of American forces, he noted, "The Americans demonstrated a mechanical aptitude at all levels that we could not match. Every American soldier seemed part mechanic, part engineer, with the authority to modify equipment as needed." This distributed innovation capability ultimately proved more significant than any single weapons system or tactical doctrine. The homemade ammunition belt that kept Sherman tanks firing for 4 straight hours thus stands as a symbol of a larger truth about modern industrial warfare. Victory belongs not necessarily to those with the best initial designs, but to those who can adapt most effectively under combat conditions. In this crucial test, American industrial philosophy, emphasizing practical innovation over theoretical perfection, proved decisively superior to the German approach. As modern military forces continue to grapple with the balance between centralized design authority and distributed innovation, the lesson of Harmon's ammunition belt remains relevant. The most effective military-industrial systems create space for bottom-up innovation while providing the standardization necessary for mass production, precisely the balance that American forces achieved in World War II. The mocking that Harmon initially endured for his garage mechanic approach to military equipment modification reflected a misunderstanding of American industrial strength. That strength lay not just in massive production capacity, but in a culture that valued practical problem-solving at all levels of organization. When that culture was fully mobilized for war production, it created an adaptive capability that even technically superior opponents could not overcome. In this sense, the story of the homemade ammunition belt that transformed Sherman tank performance represents more than an interesting historical anecdote. It encapsulates a fundamental American advantage that helped win World War II and continues to influence military-industrial approaches today. The understanding that innovation can and should come from anywhere within an organization, not just from designated experts or centralized authorities. The Sherman tanks that rolled into Germany in 1945, many equipped with variations of Harmon's improvised ammunition system, thus carried with them not just the firepower to defeat German armor, but a vindication of American industrial philosophy. They demonstrated that in modern warfare, adaptability often trumps initial design advantage, a lesson that continues to resonate in military planning to